Hi, this is Thomas. Welcome back. Today's lesson is on differential calculus, and we're going to begin to look at additional differentiation rules beyond the power rule that will enable you to work with a broader range of functions for differentiation. We'll start with the chain rule, which is what we use when we have composite functions which we want to differentiate. So let's look at the rule and then we will work through examples. An example of a composite function would be if I have g of f of x and I want to differentiate this composite function. I'm going to use a labeling system to simplify my analysis. I'll refer to the function f of x with the variable u, and that's the inner function. I'll refer to the outer function as g of u, represented by the variable y. So the derivative of y with respect to x equals the derivative of y with respect to u times the derivative of u with respect to x. Stated descriptively, we're going to take the derivative of the outer function and multiply by the derivative of the inner function. So let's look at two examples. First, y equals, in brackets, x squared minus 2x to the power of 4. This is a composite function, and part of being successful with the chain rule is being able to identify the separate functions. The outer function is the brackets, what's contained in the brackets to the power of 4, and the inner function is x squared minus 2x. So I'm going to use the label u, which is my inner function, to represent the expression x squared minus 2x. And I'm going to use my label y for u to the power of 4. The outer function is something to the power of 4, and the inner function is that something. Now let's apply the rule. My first step is to take the derivative of y with respect to u. So in the expression y equals u to the power of 4, my derivative is going to be, beginning, the derivative of y with respect to u is applying the power rule. I bring down the power 4, multiply by my variable u, and reduce my power by 1 from 4 to 3. And my second operation, the derivative of u with respect to x, going up to u, x squared minus 2x, I'm going to apply the power rule to both of my terms. X squared becomes 2x minus 2x becomes 2. In both cases, I've applied the power rule. I multiply the variable by the exponent, and I reduce the exponent by 1. In the case of the second term, minus 2 came from the original function minus 2x. So x was to the power of 1. When I reduce that power by 1, x is to the power of 0, which results in the x going away. It simply becomes the value of 1. And now I can multiply these two functions, these two derivatives, to get to the derivative of y with respect to x equals 4 something to the power of 3 times 2x minus 2. Now the something to the power of 3 is u, but u is simply terminology that I'm using for a temporary substitution, and looking back up at what u is, u equals x squared minus 2x. So the final derivative, the derivative of y with respect to x, is 4 times, in brackets, x squared minus 2x to the power of 3 times the expression 2x minus 2. Let's take a second example. Y equals 4 over the square root of 1 minus 2x. In this case, first I'm going to identify my inner function. That is 1 minus 2x. That's the expression in the radical in the denominator. And my outer function, y equals 4 divided by u to the power of 1/2. In other words, 4 divided by the square root of u, which is the same as 4 times u to the power of negative 1/2. Now I'll calculate my two derivatives. The derivative of y with respect to u. First, using the constant multiple rule, I'll bring out the 4. And now I'm going to differentiate u to the power of negative 1/2. In front of the u, I will multiply by negative 1/2, which is my exponent, times u, and my new exponent, negative 1/2 minus 1, is the power of negative 3 over 2. And so this simplifies to negative 2 u to the power of negative 3/2. Next, I will differentiate u with respect to x, and my expression u is 1 minus 2x. The 1 applying the constant rule has no derivative, it's 0. And when I take the derivative of negative 2x, I end up with negative 2, using the power rule. X is gone. X was to the power of 1. Applying the power rule, it ends up to the power of 1 minus 1, or 0. Therefore, x becomes 1. And the full value of the derivative minus 2x is negative 2. Now I can multiply my two derivatives to arrive at my final solution. So the derivative of y with respect to x is a derivative of y with respect to u, negative 2 times u to the power of negative 3 over 2. Again, u is a substitute for 1 minus 2x, and I'm then going to multiply by the derivative of u in terms of x, which is the value negative 2. And I can simplify. Notice that I'm multiplying at the very front of this expression, negative 2, and at the end, negative 2. So I'm going to simplify. Negative 2 times negative 2 is 4 times, in brackets, 1 minus 2x to the power of negative 3 over 2. These are two examples of using the chain rule to differentiate composite functions. In our next lesson, we're going to look at two new differentiation rules, the product rule and the quotient rule. I look forward to seeing you then.